So how many of you are old enough to remember the mashup era? Show of hands. All right, my peers in the room. Well, for those of you who don't know, back in the early 2000s, developers were mixing and matching all types of APIs to create these new innovative apps. And it was such a fun and creative time in web development. One of the most iconic mashups was the combination of Google Maps with Craigslist. Y'all remember this one? Of course, right? So you would search for real estate, and instead of getting like a boring list of text, you see all of the real estate mapped out for you. And this mashup was called Housing Maps. And it turned that basic search results into this interactive experience. Can y'all hear me okay? Okay, perfect. So I know that this doesn't seem like revolutionary today, but back then, this totally blew our minds. You see, because this was before Google Maps API was even a thing, right? It was literally just some regular dude named Paul mashing things up at the house, and everything was really closed back then. So being able to pull from not one vendor, but two to create something new was unheard of. So developers, they started mashing all kinds of things with Google Maps, like crime data, local events, even restaurant reviews. And the excitement and the demand is actually what led Google to release the Google Maps API. They realized the potential of letting developers build on top of their platform. And once Google opened the door, all the other companies followed, right? And so other major companies, they started providing APIs as well. And this was the beginning of the open APIs that we know today. This became the norm. This ecosystem of APIs became the norm, and developers could build new services around these offerings. Now, another iconic mashup from this era was combining Twitter and Flickr. Y'all remember that one? And everybody's probably like, what? But this is before Twitter had photo sharing, So we were really inventing things and kind of pushing these platforms to do things that they weren't built to do. But you could tweet out your latest photos right from Flickr. It wasn't long before the developers, they were mashing YouTube and Twitter so that they could do video sharing as well. And developers, they got really creative. There was a Netflix and a Rotten Tomatoes mashup that showed movie ratings right in your queue. Back when Amazon was just a virtual bookstore, y'all remember that? There was one mashup that connected your Amazon purchases with a library thing to let you organize like your book collection. And then there were even mashups that scanned your iTunes to let you know like when your favorite artists were coming to town. So this was such an amazing and fun time. There was no shortage of innovation. Now, you may be wondering to yourself, well, if mashups were all that, then, why didn't they last? And we can talk about a couple of reasons why they kind of fizzled out. So one of the biggest issues with mashups was maintenance. So the APIs would change, they get deprecated, or even sometimes just disappear. One day your mashup worked great, the next it was completely broken. And keeping up with all of these changes became a nightmare, especially since most of these mashups were like side projects for developers, right? You get excited about an idea, you tinker for a weekend, you put it out into the world. But because these projects were born out of curiosity rather than commitment, then they lack that long-term support. Well, I really missed the creativity of those days, which is why I am so excited about MCP. So it's bringing back that same energy of the mashup era, but in a way that could actually work long-term this time. So MCP, for those who didn't raise their hand earlier, MCP stands for Model Context Protocol, and it's an open standard that lets AI agents talk to different APIs, different tools, different data sources in this clean and consistent way. You can think of this like a universal adapter. So instead of custom coding every integration, you just plug in these things called MCP servers, which are basically just wrappers around APIs, and the agent just knows how to interact with them. And this makes it super easy to build the mashups because everything just plays together nicely right outside of the box. So like I said, MCPs work with AI agents. So an AI agent is a system that takes action on your behalf. So you can think of like your AI chatbots, like ChatGPT, for example, right? You give it a problem or a question or something like that, and it'll respond to you telling you how to do something. AI agents take that a step further and actually do the thing on your behalf. So they can make API calls. They can generate and execute code. They can trigger other actions within your systems. Now, MCP itself isn't a requirement for AI agents. In fact, there's many companies that are building closed agents that work specifically within their apps, right? And that's cool. I mean, you just describe what you want to do in natural language and you're able to handle it with AI, and there's no need to like hunt through the settings and figure things out. And that's extremely helpful. But the second that you need to bring anything outside into that application, you're out of luck. So that's the beauty of MCP. With MCP agents, they're not boxed into like a single application. They can connect to any tool or any service that exposes an interface via MCP. So kind of like the mashup era, but instead of wiring everything together manually, the agent figures it out and does it for you. We're back, right? Fun, fast, creative integrations, but now way easier to create. So Anthropic launched MCP in November 2024, and my company Block, as well as a few other companies, they helped out with the spec. And y'all, let me tell you, the developers are hyped.
Everyone is talking about MCPs. It's gone completely viral.
It has. The hype is real. And a lot of that is because MCPs are completely open. Anyone can build an MCP server, even if you're not the API provider. There's SDKs to do so in TypeScript, in Python, in Java, in Rust, in Kotlin, and Microsoft just launched one for C# a couple of weeks ago. And the servers themselves are open source. So they're not only open source, they're also LLM agnostic. So they work with any model, and they're agent agnostic. So they can work with any AI agent that also adheres to the MCP standard. So in less than 6 months, there's already this massive ecosystem of MCPs, over 4,000 of them, in fact. And the wild part is that only about 300 of those are from the actual vendors of those APIs. The rest, they're made by everyday developers, just like my boy Paul from the Mashup days, right? And developers everywhere, they're seeing the potential and they're jumping on board. And as go the developers, so do the companies, right? So in the last month or so, we've been seeing companies launch official MCP servers because they realize, y'all, we're doing this with or without them, so they might as well join the party. And the biggest tale was OpenAI adopting MCP rather than solely relying on a closed proprietary solution. And MCP has caught the attention of Google and Microsoft CEOs as well. Like I said, the hype is real. But let's not just go off of hype. Let's look at some actual MCP mashups. So I'm going to use Goose, which is an open source AI agent, and it's built as an MCP client. That means it can work with any of the 4,000 MCP servers out there. It lets you choose your own LLM. So you're really seeing the full potential of MCP here. So let's create one of the most popular mashups of the early 2000s, but with MCPs. So I asked Goose to make an interactive map of restaurants, and it first uses the Google Maps MCP to get the location, and then also search for those nearby restaurants. And once it has that data, it uses the developer MCP to write the web page, and then the computer controller MCP to open it in the browser. And there you have it. We have an interactive map of nearby restaurants, all done in about 30 seconds. So with just one natural language prompt, Goose mashed up several tools: the Google Maps MCP to get the data, the OpenStreetMap API in Leaflet.js to provide the tiles, the developer MCP to create the web page, and the computer controller MCP to open it up. This is the modern day mashup, y'all. Combining data from different APIs and local tools without needing to manually wire them together. Let's look at another mashup. So here's a Figma design. And to access this from my AI agent, I need to add the Figma MCP. So I'm going to install this and provide it with my Figma access token. So I also have a couple of other MCPs enabled here, like the developer and the computer controller. So let's make a mashup that asks Goose to take the Figma design and use the developer MCP to actually create the website using JavaScript, HTML, CSS. And within less than a minute, Goose has mashed together these two MCPs to complete my task. And now I want to mash with the computer controller MCP and have the agent open the website for us. And as you can see, the site looks just like the design. So with my MCPs, the agent handles combining the tools. It handles integrating the services, getting them working together. And this integration is not something that I need to maintain. At any given time, I can ask my agent to do something like this. And even if these MCPs change or the APIs change underneath them, the agent is going to grab the latest version and just figure out how to work with it. And this is why I'm so excited about MCPs. They're dynamic, they're flexible, and they're just plain fun, you know? Let's see what else that we can use MCP for to help in our developer lives. How about setting up a new project, which is a practical task for any developer? So I want to set up this Git diagram project locally, and it has an extensive stack complete with front-end, back-end, database, AI, deployment, you name it. So there are great instructions here on how to clone the repo, install the dependencies, configure the environment, spin up containers, start the database. But it's a lot of manual work, y'all, and I'd rather spend my time on something else. So I'm going to give Goose this repo and have it do it for me. And Goose is using the GitHub MCP to get the instructions from the README file, goes on to clone the repo, checks if PNPM is installed, which it isn't, so Goose takes care of that for me. Then installs the dependencies, sets up the required environment variables. It attempts to spin up a Docker container, but notices that Docker isn't running. So it opens Docker, and I get a prompt to authenticate, which I don't mind doing manually because I'm not giving these agents my password, y'all. So Goose notices that Docker is running, continues working. Its next step is to start the database. And Goose notices that the database isn't set up yet, so it tries running that script, but runs into a snag because the database needs a password. So Goose generates the random password so that it can continue its work, and now has that database running. And the last step is to start the front-end server. So I go ahead and test Goose's work by checking localhost in a browser. And voila, the environment is successfully set up in less than 2 minutes, I might add. So Goose finishes off by letting me know the ports that everything is running on. Also tells me I'll need to add some API keys to the .env file, which it was unable to access because I restricted its access with something that's called a Goose ignore, kind of like git ignore. So with a GitHub and a developer MCP, we're able to automate common developer tasks on the fly. So we've seen some cool mashups here, but I want us to take a step back and look at how all of this actually works. This is a simple example of an MCP server. So there's an official TypeScript SDK, as I said, And that lives in the Model Context Protocol's GitHub org. However, community members have been making these fast MCP SDKs. We want everything faster now, that makes MCP development even simpler. And we create an MCP server instance and we give it a name and a version. And this step is basically just setting up the server's identity. And next, you're going to want to add tools. Okay, so tools are one of the most important aspects of agentic AI. AI agents are able to execute those APIs by doing tool calling. Okay, so we add a name and a description for the tool. And y'all, please don't foobar this, because this gives the agent context about the tool. And that's how it's able to figure out, if this is the right tool for the job or whatever. Next are parameters. So just like a function, if you want a tool to do something, you provide arguments in many cases. So this is specifying that 2 numbers are needed when calling this tool. And then you provide a body specifying what happens when this tool is called. Okay. And you can add as many of these tools as you want. Now, here's a tool within the GitHub MCP, just so you can see a real example that fetches the latest GitHub message for a given owner in a repo. So the name of this tool is Get Latest Commit. Very descriptive, right? So we know exactly what it's going to do. There's a nice, clear description, which helps the LLM know what the purpose of this tool is. Now, you don't want this to be too long, okay? And I'll get back to why in a minute. But you want to keep this concise. And then in the execute function, there's the API call, and it returns the latest commit message. So nothing too crazy. I was arguing with somebody, not really arguing, but we're on LinkedIn, and they had like this prolific thought or whatever. And, it's like, oh, there's nothing special about the MCP spec. And I'm like, if you're looking in the spec, you're looking in the wrong place. We want our spec simple, The magic is what it unlocks. But anyway, I digress. So here's what's going on behind the scenes. We have the user, which is you, the agent, which is an MCP client like Goose, which has access to the tools that are part of the MCP servers that are installed. And then we have the LLM, which makes the decisions. Okay. So the user gives the agent a natural language prompt, like asking Goose to set up the project, for example. Sounds simple enough, but there's quite a few steps involved, like setting up the directory, initializing the repo, creating a README, committing the changes, So the agent takes the user prompt, it sends it off to the LLM, along with a list of the available tools. The list of tools are all from MCPs that are enabled. So this list can get quite long, and many of them aren't necessarily relevant to the task at hand. So as a user, you can add like as many MCPs as you want to your agent, but don't have them all enabled at the same time. And the reason for that is because every MCP can have multiple tools. And some of these might even overlap. So you give the LLM like this gigantic list of tools, some of them which are redundant, and this causes confusion. This is going to slow up your response time, and this is also going to eat up your LLM tokens. And that's what I was saying earlier about the descriptions, and you don't want them to be too long because all of this info is being sent with your prompt. So I see people who use Goose and other agents, and they're like, I'm running out of credits or tokens, is eating up my context window and stuff like that. All of that is because there's too much information being sent over. So you want to, if you're developing an MCP server, you want to keep it pretty tight. And as a user, what you want to do is when you start your session, kind of look through which MCPs you have installed. You might want to enable the ones that you think you need and disable the ones that you don't. And some of the agents, including Goose, are working on a smarter thing. Look, we're in the early days right now, so we got to do a lot of stuff ourselves that might look a little janky. But we're working on where it's smarter to know, okay, given this task, these are the MCPs that I should enable and I could disable the rest, All right. So the LLM is going to take all of that information, the prompt, it's going to evaluate the list of tools, and then it's going to decide which tool call should be made, and it shares that decision back with the agent. Now, here's, again, where those tool descriptions come in handy. That's how it's going to know which tool to call. You need to give it enough context to make a decision. And then the agent executes the tool call and informs the LLM of the results. And it also updates the user on what it's doing. And that was just one step of the task. So remember, there's quite a few steps to set up the repo. So this is going to loop. They call this an agentic loop. This is going to loop until the full task is completed. And the beauty here is that you don't have to worry about how all of this gets stitched together, right? The LLM is just going to dynamically choose the right tools, and the agent is going to manage this entire process. Now, there's a lot of places where you can find that directory of MCPs. Remember, I told you there's like 4,000 plus of them. I like to call these the MCP toy stores because I quite literally feel like a kid in a candy store anytime I go browsing for MCPs. The first directory was the official. So I'm giving y'all a little history here, which was like 6 months ago. But things move fast in the AI world, So the first directory was the official MCP repo. They launched with a handful of MCP reference implementations like File System, GitHub, Google Drive, Slack, and so on. And the directory is not updated often, though. So while it was the official list last November, this has become outdated as community members have made more sophisticated directories like Glamour AI. So Glamour AI has this report card feature that I really like. So I go here when I need to suss out an MCP. Now, I'm going to be honest with y'all. Like I said, this is early days, so it is the wild, wild west out here. Paul and John and Katie and everybody just whipping up MCP servers in the basement, So you want to suss it out, make sure it's of high quality. They'll even have a little grade for security. So they look through the code to make sure there's no vulnerabilities. And this report card is regenerated every time there's an update to the repo. And Post MCP is another directory. This one is my favorite. I love how clean the UX is. And you can see some indicators of the popularity of an MCP by the number of downloads and GitHub stars. And then my company Block is working with Pulse MCP on an official MCP registry to serve as this unified catalog for the MCP servers. Now, with MCPs, we are bringing back that creative spark from the early 2000s, but in a way that's practical for modern development. So whether it's for productivity or creativity or just plain fun, the flexibility of MCP means that you can do more with less effort. And the coolest part is that it's not just being run by the big companies, right? The developers everywhere are building and sharing their own MCP servers. So there's always something new to try out. If this got you curious, I encourage you to give it a try. We are having an absolute blast mixing and matching MCPs. MCP folks, are y'all having fun? Yes, of course you are. So you can start by choosing an MCP client as your AI agent. So the popular ones are Cursor, Windsurf, but of course I recommend Goose because it's open source. You can use whatever LLM you want, so it's not vendor lock-in, and it's good for more than just coding. So those are coding agents, and this one is more of a general purpose agent. And it comes with a couple of built-in MCPs right away, so you can start using it. Then you're going to want to go and explore one of those MCP directories. You'll find thousands of those MCPs already available. And if you can't find what you're looking for, again, you can always build it yourself with one of the MCP SDKs. So go mash things up, make something fun, and be sure to share it with the community. Thank you all so much.